Let's implement the store word instruction in the MIPS architecture. So in this architecture, we calculate the address where we want to store something in memory by using a base plus an offset in this. So in this case, the base is determined by the contents of the RS register, which is indicated here. So this is our base register, and it is RS. And then we're going to add an offset, which is going to be from an immediate. So here we have our immediate. This is our offset. And our immediate. And we're going to use those two to calculate where we're going to store the data, which is stored in RT. So this is our data. And our data is equal to R of RT. So how do we get this base plus offset? Well, let's take our RS value, and we want the contents of RS, so we're going to put the value 00100 as our RS value, and then we're going to get out R of RS on this line. And then we can take our offset, our immediate value, it's going to feed in here, which gives us our 32-bit immediate. We're going to add those two things together to create our address that we will send to the data memory. The next thing we have to figure out is whether we want to write word or write byte. In this case, we're doing a store word, so we get a 1 for write enable for word and 0 for byte write enable. And then the final thing is we need to get our data, so we know that RT is 00101 for 5. We're going to take R of RT, our data, the contents of that register, we're going to send them to the data input of our memory. In this case, because we're not going to be writing anything to the register file, we can set the write enable to 0. RD source is going to be don't care because we're not writing anything to the register file. ALU source 2 will be 1. The ALU opcode will be add so that we perform the addition. Now let's suppose instead that we want to do a store byte instruction. And to get a sense of how this might work, let's compare one of the important differences between a store word and a store byte. For a store word, we'd want register 4 to have an address that's divisible by 4. So something, let's say 0004 or 0008, anything that's divisible by 4 because it needs to be word aligned. For store byte, we can have our base register be any value because anything is byte addressable. And so let's say it's register 0003 is stored in register 4. And so in this case, our address would be not word aligned, it'd be byte aligned. And we could have something at, let's say, address 7 here, and that'd be totally okay. Whereas our store word would have an address that must be word aligned, such as 0008. So in order to make this okay, we would need to have our write enable for words to be 0 and our write enable for bytes to be 1, and then everything would be stored correctly. Then notably, the data in here would only take the 8 least significant bits from the data in to store into the byte.